Good morning, everyone. Let's do our quiz review worksheet today. So let me go through each of these topics, kind of give a preview for each of these topics. And we may not be able to work through the entire worksheet, but whatever we don't finish, we can pick off tomorrow, and we can also start our second review worksheet. All right, so the first type of problem is to be able to add terms together, use to understand how summation formula works, and to be able to add our terms together, starting with our lower bound and working our way to our upper bound. So we're going to do this by hand. So we're starting with a lower bound, plug 2 in for all the I values. That will give us a numeric sum, and then we're always going to add the next set of terms. So if I do plus, plug 3 in, I'll get a value, and then I plug 4. I'm going to add all those terms, and 4 is going to be the last term that I plug in for I, because that's my upper bound. All right, number 2, use sigma notation to write the sum. This is where we're going backwards. We have we have the sum information here, but we're trying to get this to be a rule. Right. So working backwards, we have to kind of play around with different patterns to see what pattern will fit into a rule. Number 3, we have to be able to find area of rectangles using approximations. So we have to build starting with our width, and then we're going to create our subintervals, and then from the subinterval we can find the y values, and we can approximate area because we're able to find the width and height for each rectangle. Number 4, we're also doing approximation using rectangles, but it's a little bit different because we have a table of values. And so the width is going to be predetermined. It's not going to be one we have to find from scratch. We can just rely on these numbers to help us find each of the widths. So to be able to pick off the correct height depending on the type of rectangles that we're creating, and also to be able to involve area of trapezoids when it's asking for it. Okay, number 5, finding area using limit definitions. So number 3 and 4, we were using a set number of rectangles, so those are all approximations. But if we push the n out to infinity, our number of rectangles out to infinity, then we're able to fill in all the gaps for our graph, and we're able to achieve exact area. Okay, so being able to use the width, the area formula, and then clean this up to the point where we can identify the parts that require summation formulas. And once we get everything to be in terms of n, then we can evaluate the limit as n approaches infinity and just look for matching degrees and ratios for each fraction. And we can work our way down to a number, and that number represents the exact area. 6 through 9 are more recent topics where we have to find the antiderivative using power rule, find the antiderivative using trig integrals, antiderivative using power rule, but we have to go through it twice, and along the way the constants will show up, plus c will show up, plus k will show up, and then finding specific expression, so having to solve for c using order pair that's provided. And I also have this formula sheet that I attached to the end of your review so that this will be good to have as you take your quiz. All the formulas that you need are available here. I'll also include this at the back as a back page of on your quiz. All right, any questions before we look at each of these problems? Any questions that you guys have? Okay, so let's start off with number 1. We're just going to find the sum and put in our I values one by one. Okay, so we start with 2, then we go to 3, and then we stop at 4. Okay, replacing all my I values initially with 2s, and then replacing my I value with 3, and then my I value with 4. All right, any questions with number 1?
Mr. Yang?
Yeah.
For these sum problems, is there a way to do them any quicker?
No, because we can do them quicker if it started at 1 and there are a bunch of terms. But for this one I give you on the quiz, it'll just be like 3 or 4 at most. So you'll just do it by hand.
Okay, thank
you. Yeah, if this was a much larger number, if there were a lot more terms, then we would try to use the formula. But this one, there's just too much going on. It's not worth the trouble to figure out a formula when there's only 3 terms to do. All right, number 2. Use sigma notation to write the sum. So the way that we're going to do this is we're going to try to get this into an expression that looks like this. Okay, we know that we're going to be always starting with 1 for these types of problems. And we're going to figure out a pattern that will allow I equals 1 to give me this term, and I equals 2 to give me this term, I equals 3 to give me this, and then I equals 4 to give me this. So the way I like to start off this process is I want to look for the easy parts first. Do I see anything in these terms that are repeated over and over again?
So, the things that are repeated are cube root of 5 minus and then the term.
Good. Right. So I like to start off with that. If you start off with that, you can kind of have some foundation to build off of. And then the rest of it, you just have to fill in, in the minus. You just have to fill in with a pattern that involves I, because I is what's causing these terms to keep changing. So let me give you some possibilities of different patterns involving I. Maybe it's involving multiplication. Maybe it's like a 2i or 3 times I or 4 times I, different factors of constants. Or it could be something involving I squared or I cubed, I to the fourth, powers of different values. Or maybe something that is an exponential, right? Powers of 2 or powers of 3 or powers of 4. Right, so those are different patterns involving i's that we can play around with to see which is the one that will fit best. Okay. Do any of those look like ones that we could use?
Maybe 2i.
2i. I think it's always a good idea when you find what you think is your pattern to actually test it out, right? It may not work for every term, so you want to test it out. So if I plug 1 in for I, 2 times 1 is 2, that works out well. Plug 2 in for I, 2 times 2 is 4. 3, I get 6. 4, I get 8. So what do I put for my upper bound here?
4.
4, because that's the last I value I put into my expression. Now, what if I had this? What if I didn't stop there, but I put plus dot dot dot? So let's say there's all these middle terms that I'm not including, but I'm showing you the last term. So this would be enough for you to create a pattern, but then you got to test out what will give me that last term. So in this case, what I value will give me this last term?
11.
Yeah. It's just a matter of kind of trial and error. So if that's the case, then I would put 11 as my upper bound if this was the problem presented. 11 times 2 is 22. All right, any questions with 2? All right, number 3, use 3 middle rectangles to approximate the area of a region bounded by our function. Okay, so the first thing we need to do is we need to find the width . And then the second thing we need to do is we need to build our number line, and the number line is going to help provide those subinterval x values. Okay, so let's identify our A, our B, and our n value. A and B are my endpoints, so 1 to 6. N is the number of rectangles, so we're using 3 middle rectangles. Okay, B minus A over N. Next up, we're going to build our number line. Okay, we're starting at, okay, careful where you start. I made a mistake on my key. I started at 0. It's not always going to start at 0, right? We're going to start at the left endpoint of your interval. Okay. We're going to be able to create 3 subintervals, and we need to find the x values at each of these subintervals. So the way you find the x value is we're going to keep adding our width to our left endpoint, and that will tell us what x value will create that width that we want. So if I do 1 plus 5/3, I get 8/3. Plus 5/3 again, I get 13/3. Plus 5/3 again, I get 18/3, which is the same thing as 6. All right, so I have an error on my key, which I'm going to fix later. Now, these are 3 subintervals that would be good if we want to find a left or right-handed rectangles, because we have subintervals with the appropriate x values, but it's asking for a middle rectangle. So we're going to find a bit more information from our number line here. We're going to pick off our midpoints. So to find our midpoint, we're going to be adding and finding the average between our subinterval endpoints. So 1 plus 8/3 divided by 2, or same thing as 1 plus 8/3 times 1/2. Okay, feel free to use your calculator. You just find the average of your two numbers. Eight thirds plus 13/3 divided by 2 gives us 21/6. If you want to reduce your fraction, you can, or you don't have to. And then average the last set of numbers here divided by 2. All right, any questions so far here?
Mr. Yang, I don't understand why you put 8/3 instead of 5/3.
We don't do 5/3 because we're not starting at 0, we're starting at 1. So if I want a width of 5/3, my next value over is going to be 8/3, because 1 plus 5/3 gives me 8/3. Because if I put 5/3 here, then my distance is not what I want for my width.
Okay, thank you.
But it will be 5/3 if my left endpoint was at 0. And I made a mistake. I started at 0. I should have started at 1. But this is correct. Okay, any other questions before we move to finding our width and height, or area? Okay, so our area formula is width times height. So my width is always 5/3, right? The distance between each of these subintervals, it's exactly 5/3. And now I want to pick off the height. The height, I got to involve the function. So right now I'll leave this in function notation. I'll say f of 11/6. Width is going to be the same for every rectangle. Okay, so now we're just entering these in for the x's, and whatever result we get, that's our height. Okay, so if you round a little bit differently, that's fine. So any questions with number 3?
Mr. Yang,
Yeah.
why did you use 11/6 and 21/6 and 31/6 versus like 8/3 or 13/3?
The reason why is because it's asking for middle rectangles. So we want to attach the midpoint to the curve and not the left or right endpoints. So if it was asking for a left rectangle, then you can just rely on these original subintervals. But middle rectangle means I need to be able to attach the midpoint to wherever the curve is.
Okay, thank you.
So yeah, it's the middle that's kind of making us look for these midpoints. Right. But we would not have to use these values if it was a left rectangle or right rectangle. Then if it was left or right, then you'll just use f of 1 for the first, f of 8/3 for the second, and f of 13/3 for the third. Good. Any other questions? Okay, number 4, use the table of values to estimate. So we're still finding areas of rectangles using or approximating area under a curve using rectangles. But this process is a little bit different because we're not going to be looking to find the width. And the width is most likely not going to be the same across all these rectangles. We're going to rely on the table of values. There's a predetermined set of widths that we're going to be using. And so something that we need to make sure that we don't do is make sure that you don't use your width formula. We use the width formula if the width is not predetermined and we're trying to create a common width or shared width, but everything is given to us within these tables, so we want to use the intervals indicated by the table. So make sure we don't use that width formula here. Okay, first thing that we're going to do is identify and make sure that we see our intervals. So our interval is going to go from 0 to 7. So we're going to start at 0 and end at 7. We're going to create 3 subintervals. Your subintervals are not necessarily going to be the same width, but they will span across the same number of order pairs within each subinterval. So this is how we draw our subinterval. You're going to start at the middle of your first order pair, and then you're going to end at the middle of your last order pair. And then when you start your second interval, you're going to start where you left off. So you're going to have a shared subinterval at starting point, and then you're going to end at the last order, the middle of your last order pair. And then same thing here, shared endpoint. So you see that every bracket that I created, every interval that I created, they all see exactly 2 order pairs. Okay. And then when we subtract these x values, that's going to tell us the width of each subinterval. 4 minus 0 is 4, 6 minus 4 is 2, 7 minus 6 is 1. Now within each subinterval, we're going to pick off the width and height. So my first subinterval, I'm looking at 0, 4, and 5, 3, and I see that my height is going to be coming from my y value column, my y value row, and I want to pick the one on the left. So 5 is the one on the left, 3 is the one on the right, so I'm going to choose 5. 4 times 5 is the area. Okay. Second subinterval, I'm looking at these two order pairs, 4, 6, and 3, 2. Sorry, 4, 3, and 6, 2. My width is 2, but I want to choose 3 as the height because I want to choose the left y value in each subinterval. And the third subinterval, the y value on the left is 2. 1 times 2, width times height. Okay, any questions with A? For part B, we're going to be using two middle rectangles, and we're going to extend from 0 to 10. Draw width the same way that you did here, but now you're going to be picking off the y value that sits in the middle of each subinterval. Okay, try that. All right, so let's check our work here. So we draw our subintervals here from 0 to 6, and then from 6 to 10. Notice each subinterval in this case has a left, middle, and right, and I want to choose the y value that is in the middle. Now, your order pair in the middle may not be a midpoint, but it's okay. We just want to choose whatever information they gave in the middle. So it could be 0, 1, 6, right? And we see that 4 is not exactly between 0 and 6. 7 is not exactly between 6 and 10, but we still, that is how we pull information if they're asked for middle rectangles. Just whatever lands in the somewhere between our two endpoints is enough for middle. So there's no need to find the average. There's no need to do any calculations. Just pick off whatever number you see in the middle. Okay, so 6 times 3, and then 4 times 3. Any questions with B? Right, part C, 3 right-handed rectangles from 4 to 10. Right, careful that you're paying attention to your interval. Right, we're not always going from one end to the other end. In this case, we're starting at 4 and we're ending at 10. Oh, I forgot to mention this. When you draw your subinterval, make sure, again, that you're starting and ending at the middle of your ordered pairs. These are some of the mistakes that I've seen that students would make where they're drawing their interval incorrectly. Their brackets are not in the right place. And if you draw it like this, you're not going to be able to pull the information that correctly. So we don't want our bracket to look like this. And also, if you're going from middle to middle, make sure that you're actually creating a shared beginning and ending point for each subinterval, right? We can't do 0 to 4 as one subinterval and 6 to 7 as the next subinterval. There's a gap here, right? And we need to adjust for that. We need to make sure we have overlapping intervals with shared order pairs, like this. All right, questions with C? All right, part D, use 3 trapezoids to find the area. So trapezoids has a different area formula. It's not width times height. It's a little bit more. It's 1/2 times width times height 1 plus height 2. So you find the width the same way as before. Create your brackets, subtract your intervals, and get your width. But the difference is that we need to pick off 2 heights values for each subinterval. And you're just going to pick off the left and the right height of each subinterval. So that means for my first trapezoid, width is 4. So I have 1/2 times 4, and then I'm going to add the heights, the left and right endpoint of each height together, 5 plus 8. Make sure that you're only picking the left and the right height for each subinterval. In this case, we're not really going to make that mistake because every subinterval only has 2 y values. But let's say your subinterval had 3 order pairs, right? And you want to use trapezoid. Then you'll say 1/2 times 6 times 5 plus 2. We don't add up all the heights in between. We only choose the ones at the end. And also, some of you may be thinking, well, what if I just use this formula where I just doubled all the heights in between and then I just included the ones at the end once? We only do this trapezoid full formula or this trapezoid approximation if there is a shared width. But we see that these widths are not shared, right? These are all different widths. So we're going to have to find each trapezoid separately. We can't resort to this. We can't merge those heights together like we would if the widths were all the same. Okay, any questions with part D? Okay, let's look at number 5 on the back page. We're going to start off understanding that we have to use our width formula and our area limit definition. Okay, first things first, let's find the width. Okay, your A and B values are provided here. Now, we're not going to have a value for n because we are not doing an approximation. We want an exact area. So we want to leave n alone because if we put 3 or 4 or 5, then we're starting with approximation. We leave it as n because later on we're going to push the number of intervals and rectangles out to infinity. And that is going to fill in all the gaps. We can go from approximation to an exact area. Right? So leave the n alone. Okay, so now we're just going to use our area formula and the limit definition and insert the information that we have for this problem. let's put the width. Oops, okay. Insert the height. So left endpoint, we start at -1. All right, do we have any questions how we got from here to here to here? Okay, so then we have to find a way to get this out of function notation involving our function. Let me call this f so it'll just be consistent with our variables here. F of x. We want to get this out of function notation with the expressions so that we can find a way to merge them, because eventually we want to be able to evaluate the limit. But right now, this is not a setup where we can merge these together. So we have to involve the function somehow. And I think the best way is to create some structure so that we know exactly where this argument is going to go. So for your function, I would highly suggest us do this first. Create a function with the x's removed, and then in place of the x, put a set of parentheses. And then if you can create the space needed for each of the x's, then you'll be able to know exactly where this argument is going to go. So are we good from this to this? All right. I'm just replacing every x I see with a set of parentheses. So now you know exactly where your argument is going to go. You have a clear place for these for our new argument value. All right, any questions with this? So now we're going to replace this expression with our new term there. Okay, here's my updated height. Okay, any questions up to this point? Clean substitution, right? Once you have this, you know exactly what's going to go in place of. Okay, so now we're just going to go through our cleanup process. Sorry, I may not have given you enough room, but we're going to FOIL this out, clean this up, distribute the negative through, combine like terms. Once our height component is cleaned up, we can distribute the width through. And then we're going to assign each term with their own summation, identify the summation rule that we're going to need, and then replace them with the appropriate summation terms. And then once everything's in terms of n, then we can do limit as n approaches infinity. Okay, so this is what happens after I want to just set up myself for my expansion. So I'm going to FOIL this out, and as I FOIL this out, I want to make sure I still leave it in a set of parentheses because don't forget, I don't want to forget about this negative distributing through. So I'm foiling this out, combining the middle terms, and here's my updated, expanded terms with parentheses. Next step, distribute the negative through. So going to change all the signs of every term in between. I'm just going to go ahead and combine these. 6 minus 1 is 5. So sign changes, sign changes. So I have my height component all cleaned up. And now I can involve my width. So distribute the width through. All exponents with parentheses and brackets have all been resolved. Now I have to just now involve summation for each of my terms. Okay, each term is going to get its own summation notation. And then within each term, I'm going to go ahead and push the coefficients out because I want to identify the summation rule that I want to replace. So I'm going to push the 15 over n out. I'll pull the 18 over n squared out. I'll pull the 27 over n cubed out. And so I'll be left with summation 1, summation I, and summation I squared. All right, any questions up to this point? So I have rules for summation 1, I have rules for summation I, rules for summation I squared. Use my formula sheet there. And now everything I see in front of me should only be in terms of n and coefficients. Within each fraction, I should be getting matching degrees with ratios that I can pull. So my first fraction, I get 15n over n. Second fraction, I get 18n squared over 2n squared. Maybe there's more terms, but I don't care about them. I just want the highest degrees with my ratio. Last term here, this is a messy thing to expand, but we only care about the highest degree. So just do 27n, n, and 2n. That'll give you 54n cubed. There's a bunch of other terms, but we already have our matching degrees, so we already have our limit for this ratio for this fraction. Okay. 15 over 1 is 15, 18 over 2 is 9, 54 over 6 is 9. And we get a real number, and this indicates the exact area under this curve between our two endpoints. Okay, any questions with 5? Okay, tomorrow we'll finish the rest of this worksheet, but feel free to work ahead if you like, just to get some additional practice. You can check the key. Tomorrow we'll finish this. We'll start with the second review worksheet. I will have a help session this afternoon. I had a help session this morning. It's recorded. Just providing some additional problems like 1 through 5. Tomorrow we'll have another day of review, and then Friday quiz. And then I sent out a reminder yesterday how homework is not going to be part of your grade. Yeah, homework is just going to be a formative grade, but no grade value attached to it, meaning it's not going to affect your overall semester grade. Okay, any questions? All right, have a great day, guys. See you tomorrow.
Thank you, Mr. Yang. Have a nice day.
You too. Have a good
Thank
day. Bye. Thanks, guys.